In this tutorial we built a custom manager page with MIGXdb, for two tables with a one-to-many relationship. We have the two tables product and category. A product belongs to exactly one category. A category can have many products. This is the initial database schema. It's in the package My Company. There are two tables, My Company Product and My Company Category. They extend XPDO simple object, so they both already have a field ID. They both also have a field called name. Let's add a foreign key field to the product table for the category. We add a new field tag, and name the field category_ID. The database type is an unsigned integer. The PHP type is integer as well. Now let's add the relationship tags to the schema. In the product table, add a tag aggregate to define the relationship. The attribute alias is like a name for this relationship. It can later be used in the code, to access the category from a product object. The attribute class defines the target class of this relationship. In the attribute local, we define the relationship field of the object we are currently in. It's the field category_ID we previously added. The attribute foreign is the field of the related object. The attribute cardinality is 1, because a product belongs to one category. The owner attribute is foreign. Use the value foreign for this attribute, if the primary key field of this relationship is in the related object. Use local if the primary key field is in the source object. Now let's define the same relationship for the other direction in the other class. There are two types of relationships: aggregate and composite. If we define the relationship in a composite tag, when we delete a category in the code, all related products get deleted as well. When we use an aggregate tag on the other hand, and delete a category in code, the related products still exist. But they now have a foreign key value, that doesn't match an existing category anymore. In this case it's probably better to use aggregate to avoid that products accidentally get deleted. We define the attributes as before. The values for local and foreign are now swapped. The cardinality is many, because a category can have many related products. Save the schema and generate the class files and database tables as shown in the last video. I have already created a standard MIGX configuration for the category table and a custom manager page to manage its data. Let's now create the configuration for the products. In the tab Settings, give this config the name Product. Scroll down to the field Unique MIGX ID. This field is used to give your grid and update window a unique ID value. If you have more than one grid on your page, you need to fill in this field, to avoid problems displaying the grids. A good idea is to use the same value as the config name, to ensure it's unique. Go to the tab MIGXdb settings and fill in the values for the package and class name. In the tab CMP settings, enter the values for the title and description of the tab in the manager page. Add the button for adding new products in the tab action buttons, and update and remove options in context menus. Create the grid columns in the Columns tab. Always make sure to include one for the ID. In the tab Form tabs, add a field for the name. Then add another field for the category ID. Set the input TV type for this field to list box. Go to the tab Input Options. Here in the field Input Option Values we have to generate a list of the available categories. One way to do this is to use a @select binding. This binding is an SQL query. We query all the data from the category database table. Make sure to return the display text in the first column and the ID in the second one. This is the simplest query string. You can append it to filter out some categories, or to sort the data differently. With Union it's also possible to add a blank option at the top. The @select binding returns the data in this format. You could also use a snippet instead, if you return the data in the same format. For example, change the binding in input option values to @chunk category options. Then create a chunk with this name and call migxLoopCollection in it, with these properties for the template and the output separator. Save the configuration, and in the top menu choose the Menus item. In the menu item for our custom manager page, add the name of the new config to the configs parameter. Use double pipes to separate the config names. Save the change, reload the manager and go to the CMP. Now two tabs should be visible, one for the categories and one for the products. When you add a new product, you can select the related category from the drop-down. To show the selected category in a grid column, we have to adjust the configuration. Go back to the MIGX Manager and edit the config product. In the tab MIGXdb settings, scroll down to the joins field and enter a JSON array in this format. The key is alias and the value is the name of the relation in the schema. In the tab Columns, add a new column. All fields from the joined category table are now available with the prefix category _. Set the value of field to category _name. In the Custom Manager page, the grid now shows the category in the newly added column. The TV type list box has different input options that are listed on this page in the MODX documentation. If we scroll down to the list box section, there is a box with all the input option names for use in MIGX. Let's copy the value. In our MIGX configuration, in the field for the category ID, there is an input field configs. Here the behavior of the list box can be customized. We set typeAhead to true, so that we can type in the list box field to filter the categories. Save the configuration, and go back to the Custom Manager page to test the change. To output the data on the front end, we can again use the snippet migxLoopCollection. Like in the last video, we provide the properties for the package name, the class name and the sorting order. But this time we also add the property joins to join the category table to the product table. Like in the configuration, we use the alias from the schema. If we don't add a TPL property, the snippet outputs the available placeholders. Viewing the page on the front end, we can see that these placeholders are all the fields from the product table, the fields from the category table with the prefix category underscore, and some additional placeholders. We add a TPL property to the snippet tag with the value TPL product. Then we create a chunk with this name, and use some of the available placeholders in the code. We could also write a custom snippet to output the data. Let's create a new snippet with the name getProducts, and paste some template code from the last video. In the code we first add our custom package. Then we define the default value for the TPL property. We create a new query for the class MyCompanyProduct. In the sort we add the class name to the sort field. Otherwise it's ambiguous what field we mean, because both tables have a name field. Instead of getCollection, we use getCollectionGraph to query both tables at once. In the second parameter we define the graph, telling the code to connect the tables using the relationship with the alias category from the schema. In the loop, we change the call of the toArray method. The toArray method converts the class object to an array. When we set the fourth parameter to true, the result also includes the related objects. We temporarily replace the output to show what fields get returned from the function toArray. Save the snippet, change to a resource and call the snippet in the content. On the front end, we can see that all the fields from the product class are present. And also all the fields from the related category table in a nested array. To make it work with our chunk TPL product, we have to replace the underscore in the placeholder category underscore name with a dot. In the snippet, we change the code to now parse this chunk for every product. Then we check if the output on the front end is correct. Another way to achieve the same is to use a join instead of the collection graph. We use the same code template as before. This time we add a left join to our query. The second parameter is the relationship alias from the schema. Then we define what columns to include in the query response. We use the method getSelectColumns to generate the list of columns. From the product table, we select all the columns. From the category table, only the column name. The array of columns to include is the fourth parameter. The prefix for the column names is the third. In the call to the function toArray, we set the third parameter to true. Just to make sure, the code doesn't execute any additional database queries. We again use print_r to output all the available fields in the array. On the front end, we can see that all the fields from the product table are present in the array, without a prefix. And also the name field from the category table, with the prefix we specified.